All right, so on Friday we did some examples like this where you had the unit circle, and so the worksheet that you were working with, it actually said like using the unit circle, and so that's what you're going to do. You're going to use the unit circle, and you're trying to find all 6 of your trig functions. All right. All right, so copy down the, the little chart, because that's what I want it to be in that order, and that's what your worksheets look like, and that's what your quiz looks like. So I'm going to put them on both. So I'm doing 1 in degrees, and then I'll do the 1 in radians also, because the main thing is you want to be able to know exactly how to find the exact trig functions, and you are going to need to know how to rationalize, but mainly you want to be able to find coterminals and be able to know how to get to that specific coordinate and know what that coordinate is. Right? So when you have something that's in radians, you always want to look at, is the denominator one of your special ones? Like, is it, first, is it an even number? Like if it's, 1 pi, 2 pi, anything that's just like a whole number pi, or if it's something that's in halves, all right? If it's in halves, it's going to end on an axis, all right? It's going to terminate on either an x or y axis when you have a denominator of 2. Anything that's a 3, 4, or 6 is going to be somewhere inside the quadrants, right? So you kind of want to know exactly where that is. And like I said, on your worksheets, you have a little unit circle already, so you don't necessarily have to, draw something like this. Right. I'm going to try to zoom this in. All right. So when you have something that looks like this is what having 1/6 increments looks like. All right. You've got your normal like x and y axis that are up here, and then you have to cut each quadrant into 3 pieces, all right, because that's your 1/6. So you have to know how to get to negative 19 pi over 6 first. So you got to think about, how would I graph that in standard form? You don't actually have to do it, you just need to know what to do. So because it's a negative, that means you're going to move down in a negative direction, and you're just going to count 19 of them, right? Now, one thing is that going all the way around the circle, that's 12, all right? Because if I have to cut each 3 of these quadrants, that's 12 to get around, 12. So 13, 14, 15, 16, 17, 18, 19, all right? So this coordinate right here, that's on the terminal side of your graph. So when you're moving around in a negative manner, all right, I'd have to count 19 of those 1/6 increments, and that would be the point where I terminate. All right, so you either need to remember what that is, or you're going to need to try to think about that shortcut. All right, and so this bottom coordinate right here has the √3/2 and 1/2 as its coordinate, because if you use that formula of √1, √2, √3, that's the bottom line, and then it starts the pattern back up again. And so I always kind of think about that in my head, that it always goes down and then back up. So if this is the coordinate here, then that means that over here it's just going to be a negative √3/2 and 1/2 for that terminal coordinate. Right? So on your quiz, there are things I want you to be able to do. I want you to be able to say that the coterminal angle on that unit circle is the same as 5 pi over 6. Like if I actually look on my unit circle, that's the one that I'm going to see on my graph. Right? At that point is the coordinate negative √3/2, 1/2. Right? So you're going to need to identify that coterminal angle, like where did I actually stop when I finally stop moving around negative 19 pi over 6. Right? So again, you have to remember that your cosine theta is always the first part of the coordinate, and sine of theta is always the second. And if you do that, then you can start answering the rest of the questions. So your sine is going to be 1/2. Cosine is negative √3/2. Now, if you use the shortcut that sine over cosine or y over x is going to be your tangent, you need to cancel out the 2's. And your tangent looks like negative 1 over √3, but I'm putting it down there because that's not your final answer. You have to remember that you have to rationalize. So the actual rationalized is negative root 3 over 3. So if you multiply top and bottom by the square root of 3, this is what your answer looks like. Right? The reason why I kept this off to the side is because when I start flipping the fractions for cotangent, I just want to write the reciprocal of the one that was unrationalized, so that way I don't have to deal with rationalizing a second time. Right? Same thing over here, cosecant is going to be just a positive 2. And then secant, you are going to have to do some rationalizing again, because you can't leave it as negative 2 over root 3. When you rationalize, it's negative 2 root 3 over 3. And some of these you're going to start being able to do in your head, because you're going to see it's going to be the same every single time you flip that fraction. Right? So I'm not showing you how to rationalize. If you need to actually write it down, that's fine, but I just want you to be able to get it right. So this is what your work is going to need to look like on your assignment today, and also on your quiz on Wednesday. All right. So if you can't pick it out, if you can't find where this actually terminates, just by looking at the circle, and you have to start moving around, this is what you're going to need to do. All right. So find your coterminal, identify the coordinate, and then you can answer the rest of the questions. Right. I think in radians it's actually a little bit easier, just because you can count like sixths and quarters and things like that. I think the ones that are harder are the ones like this, where you're in degrees. Because when you're in degrees, you have to find something that's a positive degree first. In this one, I'm not really going to draw like I did that one. But if you have negative 480 and you add 360, one rotation, you're still in a negative direction. So you'd have to add 360 again, so that way on the circle, you can say that this is coterminal to 240 degrees. So you need to find the coterminal angle that is a positive coterminal when you have negative degree measurements. And that way I can start finding that information. All right, so coterminal angle, that was 240 degrees. All right. And at 240 degrees, that's down here. All right. And so that is going to end up being a coordinate that's negative 1/2, negative root 3 over 2. And now, I'm going to tell you the way that I know that is because that's the mark that's closest to the y-axis. And if I look at this line up here, all right, if I think about this coordinate that was up here, which started the process, which was 1/2 and root 3 over 2, all right, that starts the process of me moving my way down through pi over 3, pi over 4, and pi over 6. And if it's along the same line, then it's going to end up being the same coordinate, just negative, negative by being in the fourth quadrant. So some of those lines that we drew, you want to be able to follow the line down and use the same coordinate and just change the signs in that quadrant. Right? And then everything that you do now is going to be with that coordinate. Right? So sine is negative root 3 over 2. And cosine is negative 1/2. And you have to remember a negative over a negative turns this to a positive root 3. And so now when you start flipping your fractions, now cotangent, this would be the one where it's going to put a root 3 in the denominator, but that needs to change. Everything is going to just now start flipping. But you see how, like last time, I had the a negative root 3 over 2. When it changed, all right, I'm going to end up having to rationalize this as well. So sometimes, especially when you've already done some of this work on these worksheets, if you see one that you've already spent time rationalizing, you're going to start probably memorizing it pretty quickly. Right? And so this is what you got to do. All right, all of your work, if it's not something that you can see automatic on here, all right, you need to find its coterminal that is in the positive 0 to 360 or 0 to 2 pi area. So coterminal, coordinate, answer the 6 trig functions. The other one that I wanted to do wasn't necessarily like one of these two. It's one of the funky ones. And so I'm actually going to move it down a little bit. So what if like your theta is just 3 pi over 2. So something where it's just an automatic, it's just on there. All right, so when you're at 3 pi over 2, you've terminated right here. And so that's your coordinate 0 and -1. You still need to be able to write reciprocals even though they don't look like fractions. All right. So like in this case, your sine of theta is still the y value, which is -1. Right. Your cosine value is 0. But when you write tangent, if tangent is the y over the x, that means you are just now putting a 0 in the denominator. And I see some of you writing like this and leaving it that way. You can't do that, right? If you have a 0 in the denominator, it needs to say undefined. So either you can write UND or you can actually write the full word out, undefined. Right. When you write the reciprocal of a -1 for cosecant, it's the same thing. Right? Flipping a -1 top and bottom still keeps it a -1. But now like cosine, if 0 is in the numerator, then flipping it puts it in the denominator, which is now undefined. So having one of your coordinates as 0 means that one of the pieces is going to be 0, but its reciprocal will be undefined, and then vice versa. If tangent is undefined because 0 is in the denominator, then cotangent now puts 0 in the numerator, and that's just 0. So having a 0 up top is fine. Having a 0 on the bottom isn't. And so you're going to need to be able to do these 3 and then reciprocate them. So it doesn't matter how many times you go around the circle. It doesn't matter if I write 7 pi over 2, -7 pi over 2, 15 pi over 2. Anything with a 2 is going to land on one of those axes. And anytime you land on an x or y axis, you're going to have a 0 or undefined situation happening.